Now, what is meant by this regulation? The process of generating constant output voltage with the variation of input parameters and output parameters is called regulation. Once again, I repeat, the process of generating constant output voltage with the variation of input parameters and output parameters is called regulation. Before going to this line regulation and load regulation, I will discuss few topics here. Here they are saying that the process of maintaining output voltage is constant. That means this is constant. I'm assuming this is my load resistance. That means I'm going to measure the voltage across this load resistance. I'm going to measure the voltage across this load resistance. That means here we have to maintain this output voltage as constant. What are the parameters affecting this output voltage and the input parameter as well as output parameter? That means this supply voltage as well as this load resistance. These two parameters are affecting the output voltage. These two parameters are affecting the output voltage. That means if you increase or decrease the supply voltage, otherwise, if you increase or decrease this load resistance, there is a change of this output voltage. But because of the Zener diode present in the circuit, we are maintaining the output voltage as constant when you are varying the input parameter as well as output parameter. Okay. Now, depending upon the parameter varying, we have two regulations. Once again, I'm repeating. Depending upon the parameters varying, we have two regulations. That is line regulation and load regulation. What is meant by the line regulation? The process of generating constant output voltage with the variation of the input voltage at constant load is called your line regulation. Here, once again repeating, the process of generating output voltage is constant here. That means here we have to maintain constant output voltage by varying this input voltage, yet constant load resistance. Is called a line regulation. Now here, how the Zener diode is maintaining the output voltage as constant. When you vary the input voltage. Okay. To discuss this topic, I am going to write the KVL and KCL. I'm going to write the KVL and KCL. First, apply the KVL at input side. First, I'm going to apply the KVL at this input loop. Now here, this is your voltage rise and VI is your voltage rise, whereas this is your voltage drop. This is also voltage drop. Voltage across resistor is drop. Voltage across Zener also drop. Now, according to our KVL statement, voltage rise is equal to voltage drops. That means VI is equal to voltage drop across resistor is given by V is equal to I into R. Plus voltage drop across the Zener diode is Vz. Okay, that's why VI is equal to IR plus Vz. From this equation, I am writing the I and I am writing the equation for I. Now I is equal to VI minus Vz by R. VI minus Vz by R. Okay. Similarly, I am writing the KCL at node A. I am going to write the KCL at node A. I am going to write the equation at KCL equation at node A. Now, where is node? Here we have the node. I am assuming this node at A. Okay. Now, if you apply the KCL at this node, what will happen? See here. Now, current I is entering into this node. And after IZ is away from the node. Similarly, IL also away from the node. From that, KCL states that algebraic sum of the currents entering at a node is equal to the algebraic sum of the currents away from the same node. That means I is equal to IZ plus IL. See, I is equal to IZ plus IL. Okay. I written these two equations, equation 1 and equation 2, by applying the KVL as well as KCL. Okay. Now see here. Now coming to the actual topic. Now when you are increasing the supply voltage, nothing but VI input voltage. what will happen to this equation? Here, when you increase this input voltage, already this VZ is constant. Why? Because here the Zener diode is connected in reverse bias. If you observe the circuit, the Zener diode is connected in reverse bias. Here, positive connected to the anode, negative connected to the cathode. That means the Zener diode is connected in reverse bias. In the case of the Zener diode is going to act like a voltage regulator. That means it is having the constant voltage. Here it is having the constant voltage. So here VZ is constant and resistance also constant. Here this resistance is constant. Here this resistance is constant. Okay, VZ constant, R constant. If you increase this VI, what will happen to the I? I is going to increase. Why? Because I proportional to VI. Why? Because these two are constant. I proportional to VI. It means when you increase this VI, when you increase the input voltage, I is going to increase. I is going to increase. Now here, and after when you increase input voltage, Zener current is going to increase from minimum position to the maximum position. Already I discussed in the case of voltage current characteristics of your Zener diode. That means when you increase the supply voltage, after reaching the Zener voltage, the current is going to increase. The current is going to increase from minimum position to the maximum position. That means here, overall we can say that when you increase the input voltage, I is going to increase, IZ is going to increase. If these two are going to increase, what will happen to this load current? Here, I is increasing, IZ is increasing. Then IL must constant to satisfy this equation. To satisfy this equation, IL must constant. Why? Because I is increasing, IZ is increasing. So that's why IL is constant. If IL is constant, what will happen? Here, from this circuit diagram, IL is constant, RL is already constant. Why? Because in the case of line regulation, input varying, output constant. Here, IL constant, RL constant, then output voltage also constant. Now here, output voltage is constant. Similarly, when you decrease the input voltage, listen carefully. When you decrease the input voltage, what will happen? When you decrease the input voltage, here, these two are constants. Here, I is proportional to VI. If VI decreases, I also going to decreases. Here, I is decreasing. Similarly, if you decrease the input voltage, then Zener current also going to decrease. That means we are decreasing this input supply voltage. Then Zener current also going to decrease. If these two components are decreasing, what will happen to this IL from this equation? Here, I is decreasing, IZ is decreasing. To satisfy this equation, IL must constant. Now, sir, IL is constant. If IL constant, RL is already constant. Now, if these two are constant, output voltage is constant. Here, output voltage is constant. It means when you increase the input voltage, when you decrease the input voltage, the output voltage is constant. Okay, once again I am repeating. See here, when you increase the input voltage, the input current is increasing from this equation. See here, and the Zener current is increasing. If these two currents are increasing, IL is constant from this equation. If IL is constant, V0 is constant. Why? Because RL is already constant. V is equal to I into R. If these two are constant, output voltage is constant. Similarly, Vi is decreasing. From this equation, I is going to decrease. IZ is going to decrease. If these two are decreasing, from this equation, IL is constant. If IL constant, RL is already constant. Then V is equal to I into R. Output voltage is constant. This is about your line regulation. Now see the load regulation. Now see the load regulation. See, the process of generating constant output voltage with variation of the load at constant input voltage. Once again I am repeating. See here the output voltage is maintaining constant by varying this output parameter. Here output parameter is varying at constant input voltage. At constant input voltage. Okay. The process of generating output voltage is constant by varying the output parameter at input parameter is constant is called your load regulation. Okay. Now here, how this is maintaining constant and how this is maintaining constant output voltage. Now here, again I am writing the same equation similar to this equation. Again I am writing the same equations here. Here, KVL at input side, same equation. KCL at node A, same equation. Now, how the output voltage is constant? By varying this load resistance. Okay, I'm increasing my load resistance. When you increase the load resistance, the Zener current also going to increase. When you increase this load resistance, the Zener current also going to increase. If the Zener current is increasing, here before this concept, first understand this equation. Now here I am explaining this equation. I is equal to Vi minus Vz by R and D. See here, input voltage is constant. Why? Because in the case of load regulation, input constant, output is going to vary. Here input voltage is constant and Zener voltage also going to constant. Zener voltage also going to constant. And this resistance is constant. That means in this equation, RHS said all are constant. Input voltage constant, voltage across Zener diode constant, resistance also constant. If all these parameters are constant, what will happen to the I? I also constant. See here, I also constant. Okay. Now come into this topic. When you increase the RL, IZ is going to increase. If IZ increases, what will happen to this load current from this equation? Now here, from this equation, we are saying that I is constant from equation 1. From equation 1, we are saying that I is constant. And here, when you increase the load resistance, IZ is increasing. When you increase the load resistance, IZ is increasing. Here, when you increase the load resistance, here IZ is increasing. If IZ increases, already here I is constant. Already here I is constant. In this equation, I is constant and IZ is increasing. To maintain this LHS as constant, IL must decrease. IL must decrease. Okay, IL must decrease. Now here, if IL decreases, I constant, output voltage is constant. Why? Because here, from here, RL is increasing, IL is decreasing. Then overall output voltage is maintaining constant. Okay. Similarly, observe this case. If RL decreases, what will happen? If RL decreases, IZ is decreasing. If RL decreases, IZ is decreasing. See here. If IZ is decreasing. If IZ decreases, if IZ decreases, what will happen to the IL? IL must increase to satisfy this equation. When the load resistance is decreasing, IZ is decreasing. To maintain I as constant, IL must increase. If IL increase, I constant, output voltage is constant. Here, IL is increasing, RL is decreasing, output voltage is maintaining constant. Now this is about your load regulation and line regulation.